Hi, I am Revathi. I am working as assistant professor in SNS College of Engineering in Department of Artificial Intelligence and Data Science. Today we are going to discuss the topic about path vector routing. Let's talk about path vector routing. So we have already seen how link state and distance vector routing work. They basically try to find the least cost path through the network, but that is not always ideal, right? Sometimes the shortest path is not the best one, especially when you care about things like trust, reliability, or specific policies. That's where the path routing, vector routing comes in. It is different because it doesn't just blindly follow the cheapest route. Instead, it follows the source, that is the sender, to apply its own rule or policies to decide how packets should move through the network. Think of it like this. Say if you're planning a trip on Google Maps, it shows you the fastest route, but you might avoid toll roads, prefer to drive through scenic areas. That is exactly what vector routing allows, custom routing based on your preferences. Now we will see about limitations of least cost routing. Now here is the issue with the usual least cost routing methods. Let's say there is a part of the network you don't want your data to pass through. Maybe it is insecure, congested, or unreliable. With link state or distance vector, you don't really have control. If the part of the shortest path, your data will still go through it. Imagine you're sending money to your friend who would rather not go through a middleman. If you're not trust, if they charge less, path vector routing fixes this. You can say avoid the part of the network even if it is cheaper, and the protocol will follow your rule. It gives me the more control to the sender. Spanning tree in path vector routing. Let's talk about how this all fits into the network structure. In path vector, routes are built around what is called a spanning tree. But unlike other routing protocols like distance vector routing protocol or link state routing protocol, this tree is not based on the cost. It is based on your policy. So if you're the node, you basically build a custom tree from yourself to all other destination, and it reflects your preferences. For example, think of a delivery service that wants to avoid certain cities because of traffic or delays. Even it adds a few extra miles, the delivery path they choose becomes their version of a policy based spanning tree. So how does this all begin? When a node starts up, say a router, it doesn't know anything about the network. So it starts by saying hi to its neighbors and asks the basic information. Based on that, it builds an initial map of where it can go and who it can talk to. It is like moving into the new apartment. You introduce yourself to the neighbors, learn who they are, and ask who else do you know around here. Based on that information, you start forming a mental map of the neighborhood. That is exactly how the router being builds its path vector. Once the initial vectors are built, nodes start sharing them with each other. But here is where it gets interesting. They update their vectors not just based on the cost. Cost means distance. Not based on the cost like Bellman-Ford algorithm would do, but based on their own rules. In path vector routing, It follows their own policies. It will send the data from source to the destination. Let's say you hear from your friend that a new route opened up. Normally you would just take it, it is faster. But maybe you have a rule like only take highways or avoid downtown after 5 p.m. So you update your route based on your personal rules. In networking, routers do the same with path vector routing. They apply their own logic, not just what is the cheapest or fastest. Thank you.